Hi everyone, this is problem number 16 from Reasoning Holiday Walker from chapter 26, which is actually the current and resistance. In this problem, it said that copper and aluminum wire are being considered for a high voltage transmission line that must be carry a current of 60 ampere. The resistance per unit length of this wire would be 0.15 ohm per kilometer. Densities of this copper and aluminum are 8960 and 2600 kilogram per meter cube respectively, which is actually the mass density. Now we have to find out that current density and the mass per unit length of this wire, copper cable and aluminum cable. They also provide us that resistivity of this copper and aluminum wire, which are actually 1.69 into 10 to the minus 8 ohm meter for copper wire and 2.75 into 10 to the minus 8 ohm meter for aluminum wire. Now we have to find out the current density and that mass per unit length of this wire. Okay, let's start. First, I'm going to find out the parameter of this wire is given over here. I'm going to write, say that current of this wire, let me write it over here. Say the current of this wire must be 60 ampere and the resistance per unit length I express in that form is that resistance per unit length, which would be 0.150 ohm per kilometer, and the mass density I'll write down rho m for copper is 8960 kg per meter cube. I write down the rho m stand for the mass density, and rho m for aluminum, which is the mass density of the aluminum, is 2600 kg per meter cube, and the resistivity of the wire copper is 1.69 into 10 to the minus 8 ohm meter, and the resistivity for the aluminum wire is 2.75 into 10 to the minus 8 ohm meter. Now we have to find out the current density, which is J, and also that mass per unit length, which is expressed by the lambda. Actually, mass per unit length would be Watt. Find the current density. We define J actually current per unit area, which is unit would be ampere per meter square. Now the current is given. Now how I'm going to find out that area? To find out the area, we are going to use, say that definition. We know that we have to find out that area in a form. Say we know that the resistance of a wire is equal to rho resistivity length into area, right? We can rearrange this equation in a form like that. Resistance per unit length must be equal to rho by A, which would be definitely resistance per unit length would be 0.150 ohm per kilometer, right? Or we can write down that area from here actually that we needed. Area from here we can write, which is that resistivity divided by 0.150 ohm per kilometer. Fine. So I'm going to use that formula to find out that current density for both copper wire and for that aluminum wire. So we can write So current density J would be I divided by A, which is I into A is basically rho. Rho is actually the resistivity over here. Rho divided by 0.15 ohm per kilometer, right? If you solve this one, you will find out that this current density is going to be basically I into 0.150, right, divided by resistivity into 1000, which is I convert to that kilometer into the meter. Now if you plug in I is 60, this is 0.150. Now the resistivity of the copper wire is 1.69 into 10 to the power minus 8 into 1000. If you solve, then you will find out J would be 5.32 into 10 to the power 5 ampere per meter square. So that should be the current density of that copper wire. So this is actually that answer. Now for mass per unit length, mass per unit length, which is lambda, would be m by L. So now we can find out that ratio from the definition of the mass density of a system we define, rho m, actually mass per unit volume, that we can also write on volume as if area into length, right? Area into length, that will give me the volume. We can rearrange this equation. In that case, mass per unit length would be mass density into area, right? Now the area we have find out already that from previous case, right? Area is resistivity divided by mass per unit length. So that's why I can write it would be, area would be rho into 0.150 ohm per kilometer, right? Then I can write, so lambda, actually the mass per unit length, would be mass density resistivity into 1000 divided by 0.150. That would be the case. So now I'm going to plug in the value of this one. So mass density of that copper wire is 8960 kg per meter cube, and the resistivity of the copper wire is 1.69 into 10 to the power minus 8, and that 1000 divided by 0.150. So if you solve, then you will find out that mass per unit length of this copper wire would be 1.01 kg per meter cube. So this is the answer for that copper wire. Now for aluminum wire, we can find out that current density for aluminum wire, the current density J would be I'll write in terms of that instead of the I. Right, look at this that equation. I into 0.105. So I into 0.150 divided by resistivity into 1000. Now 60 into 0.150, and the resistivity of the aluminum wire is 2.75 into 10 to the minus 8 ohm meter into 1000, which actually that kilometer I convert into the meter. So that's will be give me basically 3.27 into 10 to the power 5 ampere per meter square. So this is will be that current density for this aluminum wire. Fine. So this is the answer. Now the mass per unit length. Now mass per unit length, which I formulated basically lambda for m by L, which we find out mass density into resistivity into 1000 divided by 0.150. Now I'm going to plug in of this value. So mass density of this aluminum wire is 2600. Resistivity is 2.75 into 10 to the power minus 8 into 1000 divided by 0.150. So if you solve this one, then you will find out that lambda would be mass per unit length of this aluminum would be 0.476 kg per meter. So this is actually be that mass per unit length for this aluminum wire. Okay, thank you very much.